Hi, I am Vinod Kumare, studying in Sri Venkateshwara College of Engineering, Department of Electronics and Communication Engineering. Today we are going to discuss about properties of Fourier transform. The Fourier transform is a powerful tool used in various fields such as signal processing, image processing, communication engineering. It has several important properties which are: the first one is linearity property. The Fourier transform is a linear transformation. If we add two signals, their Fourier transform can be added. And if we multiply a signal by a constant, the Fourier transform is also multiplied by the same constant. Mathematically, this property is stated as follows: f of af of x plus bg of x equal to af f of x plus bf g of x, where a and b are constant, f of x and g of x are signals, and f of f represents the Fourier transform operator. Proof: using the definition of the Fourier transform, we have f of af of x plus bg of x equal to a integration of af of x plus bg of x e exponential e power j minus j omega t dt. A integration of f of x e power minus j omega t dt plus b integration of g of x e power minus j omega t dt. A f of x plus b f g of x. Second property is time shifting property. The Fourier transform of a time shifted signal is obtained by multiplying the Fourier transform of the original signal by a complex exponential. If a signal f of x is shifted in time by t naught, then its Fourier transform will be given by f of x minus t naught equal to e power minus j omega t naught into f into f of x, where t naught is a time shift. Proof: using the definition of the Fourier transform, we have Fourier transform of f of x minus t naught equal to integration of f of x minus t naught e power minus j omega t dt. Integration of f of x e power minus j omega t plus t naught into dt. E power minus j omega t t naught integration of f of x e power minus j omega t dt. E power minus j omega t dt into Fourier transform of f of x. Third one is frequency shifting property. The Fourier transform of the frequency shifted signal is obtained by multiplying the Fourier transform of the original signal by a complex exponential. If a signal f of x is shifted in frequency by omega naught, then its Fourier transform will be given by Fourier transform of f of x e power j omega x equal to Fourier transform of f of x into delta of x. Fourier transform of f of x e power j omega x equal to integration of f of x e power j omega minus omega naught x into dx. Integration of f of x minus t e power j omega t e power minus j omega t omega naught t dt, where t equal to minus x. Fourier transform of f of x into integration of delta omega minus omega naught e power j omega t dt. Fourier transform of f of x into delta of omega minus omega naught. The fourth property is time scaling property. The Fourier transform of a time scaled signal is obtained by scaling the frequency axis of the Fourier transform of the original signal. If a signal f of ax is scaled by a, then its Fourier transform will be given by Fourier transform of f of ax equal to 1 by magnitude of a Fourier transform of f of x into omega by a, where a is the scaling factor. Using the definition of the Fourier transform, we have Fourier transform of f of ax equal to integration of f of ax e power minus j omega x dx. 1 by magnitude of a integration of f of x e power minus j omega a omega by a into x into dx, 1 by magnitude of a into f of x e power minus j omega by a. Thank you.